So my name's Nick. My background's pretty much in enterprise dev originally, I guess, if you haven't met me before. Though through that I've ended up involved in a whole lot of open source work. You probably come across AutoFac in your travels, which was one of my early projects. A couple more things like that along the way. This talk's about Serilog, which is an open source library that I'm working on at the moment. In case you're in the wrong room, you can. Okay, and if you right down the front, you see I've got a little mini LCD screen here on the back of the monitor so you can get a good view. Actually, no. But before I forget, if you want any of the very last run of the original Serilog stickers, I've got a couple, and I keep forgetting to pass them out, so there's those ones. So we've got an hour. We probably won't need every minute of that. So there's plenty of time for questions at the end, and I'll make sure I spend some time out by the coffee cart if you want to have a chat. So we'll just jump right into it. So everyone, I assume, has done some work with app logs over the course of their development so far. Yeah? How was the experience? Was it enlightening? Satisfying? I don't know. I think the most terrifying moments in my software development life have often been accompanied with stack traces and logs. So they give me that little feeling of apprehension. But there's also something very satisfying about digging through an app log, whether it's trying to work out what's going wrong in a system, why performance is poor, or just really to understand better how the system behaves in a range of different circumstances. The thing that gets me, though, and the reason that I've been pulled into really thinking a lot more about them is that in contrast to just about everything else we do, whether it's the work we do with databases or web APIs, or other kinds of eventing like event sourcing, application logs have been left in a very unscientific kind of territory. The feeling that you get when you munge through a log with regular expressions or with text search is not, it's satisfying almost because you achieve something in spite of all of the friction that was involved in the process, right? Does that pretty much sum it up? Yeah. So I guess the beauty of logs is that because they're unstructured and free form, it's very quick as a developer just to go and dump some kind of data into a log as the mood takes you as you're writing code, leaving yourself a little trail of interesting things that you might want to pull back out in the future. And you can do it speculatively because it's so cheap. And that log becomes this kind of superset of all of the other information in your app, like with interactions with other APIs and the state changes that the app goes through itself. The vexing thing is that those very characteristics that make application logs so interesting also are a big part of why they're so frustrating. And that really brings us to Serilog, which is the project that we're here to talk about. It's a solution to some of those issues by taking a little bit of a fresh look at app logs in .NET. It's been around for 4 years, which is crazy. It makes me feel much older than I probably should feel. It began as a pretty small-scale open source project, but especially in the last couple of years, it's picked up quite a lot. I originally gave this talk in Oslo in June, and I have to confess to recycling a few slides. Now, so we had 2.5 million downloads on NuGet at that point. I don't know whether the metric is itself very scientific. And in the couple of months since, we're now up to 3.4 million. So the growth of Serilog is definitely on that exponential kind of curve. And I think that since you've all spent a lot of time in .NET, that's maybe even slightly surprising because we've got nlog and we've had log4net since way back in the very early days. And they're really mature, capable, battle-tested libraries. So coming along with a new logging library, there has to be something particular about it that makes it, that makes people actually consider leaving those very comfortable existing tools and trying something new. And Serilog is one of those things. I think we've got about 80 contributors across all of the different repositories. We've got about 59 repos on NuGet, I think. And it's completely contributor-driven now, I think. So anyway, what this talk is not. The thing about a logging library is that at this configuration level, they're all pretty much the same. Like you'd expect that because Serilog is fairly new compared with log4net or with nlog, that we might have a few more modern kinds of sensibilities in the API, like configuration is done via code primarily rather than being through the long esoteric XML DSLs, which now look really tired against the JSON sort of syntax that we're adopting in things like .NET Core. It's also been born into a kind of a more modern .NET, so it's had good support for async and those kinds of things built right in there from the start. Other than that, though, the goal of Serilog wasn't anything like building a new, better logger configuration API. You can really understand almost everything there is to know about configuring Serilog from this slide, and this is about the extent of how much we'll dig into this side of Serilog. You can see that it's configured with the typical kind of targets, like you can log to the console, you can log to a file, and you can log at levels, so you might log less interesting messages at the debug level and only turn those on when something's gone wrong, and you can log errors at the error level. So these are kind of the bread and butter, and these are not the things that Serilog was about changing. That last point as well is an interesting one. Serilog also is a bit opinionated in that it doesn't actually have any static state by default, which is another little twist. So the API of Serilog is really designed as just building little generic event pipelines, and you can construct one logger or you can construct 100. We don't force you into having any kind of one global logger for your app, although that's often the way that people use it. So what the talk is about, and hopefully to inspire you to spend a bit more time looking into Serilog, is the couple of concepts that make Serilog novel and a more interesting subject to dig into. Those two, the way that Serilog captures events, and of course that's really the primary kind of reason that Serilog was built. How can we make logs both trivially easy to capture as well as trivially easy to process with software and tools offline when we're actually going to do analysis. The second thing that we'll do is, off of the back of, I guess, building more structured logs, events in Serilog have a lot more of a first-class nature, and the second part of the talk we'll look quickly at event enrichment, which is how Serilog makes you able to join the dots in a very large base of a very large volume of logs, which is typical of apps today. Part one, message templates. So a little bit of a historical view. So we're not really the first to consider this problem. Text logging is the primary kind of thing that people think of when they think about logs. And that's the printf debugging that we've all done since we were running BASIC on a Commodore 64. A long time ago and to the present day, another school of thought has existed, which is that instead of actually writing out lines of text for logs, we should be writing out structured events that have properties. And you can see the left-hand example with text logs show that we're capturing really a string describing, say, a transaction being committed here. And on the right-hand side, we've got exactly the same information, but with my very hacked-together pseudo-logging API, we've got a first-class property describing what the event is, its commit, and then the amount of time that the commit took. And you can see from the output on the left the strengths of text logging. You don't have to really do anything special to parse the log statement that's in the code. That's about as simple as it could be to record an event like that. And in the output, you've got all of your human perceptual system finely tuned for parsing large amounts of text. And you can read it like a narrative, like the app started up, we took an update request, we committed something to the database, and you don't actually even really acknowledge to yourself that you're having to parse that to get some information out of it. And when something's gone wrong in an app, that's really important because the pressure is on, you've got to figure out what's going wrong, you don't really want to spend your time dealing with the kind of dump of JSON that we see on the right. The cons of text logging, of course, are that of those events, there's not really anything particular that ties together the commits versus the updates, except for the fact that they've got some common words in each of them. So when it comes to actually going and taking that list and asking the question, well, what's the average commit time, even though it's easy to read, it's very hard to quickly pull that information out, and also writing regular expressions that pull out pieces of text, convert them into numbers, and then deal with them is a menial process that detracts from the time you could actually spend understanding the log better. So on the right, the solution to this is that we recast events as events, which makes a lot of sense. It's really the natural way to think about logs, I think. And in its favor, imagining a query that goes through and filters those events by the event being a commit, and then goes and averages out that elapsed property, it's a much easier task to have as a programmer. And if you were doing some diagnostics and you had a stream like that, and you knew what information you needed, you could get it out very easily, probably without having to really do any extra parsing or anything beyond what you could do with some JSON and some C#. Of course, the downside is that this is when you know what you're looking for. If you don't know what you're looking for, then trying to make sense of a big ream of text, I've probably created a straw man here by printing JSON to a console, right? Because you can print JSON pretty printed in a browser, but you still have that problem that you have to look at each line of an event that's written this way to try to extract some information from it. Now, okay, of course, why don't we just combine both approaches? We'll have a message and we'll have some structured properties as well. And historically, people have tried that a number of times. The problem turns out to be that in both cases, you end up having to actually invest more effort up front in order to take both sets of data. So if you're going to write a message and you're going to write some properties, then it's going to take more. There's going to be more friction at the development end, and you don't necessarily get all the benefits at the diagnostics end because you haven't necessarily got all of the things that were interesting in the message also represented as properties. And there are a few different takes on this with different approaches. None of them has really taken off. And today, text logging is still number one, and that's still what we see in nearly 99% of apps. Unless anyone's doing structured logging without Serilog. Yeah? No? Oh, sorry. Clicker's getting a bit eager. So if we really do want to solve this problem, though, if we go back and look at the text log that we've got using a format string here, assuming you're all familiar with C# and .NET format strings, when we started out, we actually did have a separate representation of the event that's going on and that payload. It was in our application when we were writing the log message, and we just jammed those things together to make the message, and we lost that structural information by pushing everything down as text. But let's say if there was some magic that we could do, we don't necessarily have to render the whole thing directly immediately. We could conceivably take the format string and we could keep hold of that elapsed timing and store those in an event somehow. And then when we get down to the point that we want to render it to the console, we get the exact same human readability as we had before. But that magic box in the middle, perhaps we could do something to also keep the structure around so that if we want to do the mechanical analysis, then we have the option of turning that on. And that is the essence of Serilog, and hopefully we will see. Oh, my window layering is not ideal. There we go. So what we'll see, here we've got a very short program. I believe that if you can't demo it with a console app, it's too much to take in. So we've got a very short program. It's a sophisticated hello world. This is Serilog being used to write a stream of events that include the counter and a username, so a piece of text and a string. So if we run that up, okay, Visual Studio. You see right away that Serilog is a bit different. And this is the first kind of place where the fact that the event is represented with more than just a blob of text becomes obvious, because we're writing out to the console, but in homage to the Visual Studio 6.0 color scheme that I think was there for C++ in those early days, the numeric values, they've kept their type, and they've come out as magenta, and the string values come out as a nice cyan piece of text. And so this is giving you a clue that under the hood, there's more happening in Serilog than meets the eye. But on the surface, we've still got a format string, and we're writing out the same information as we did before. For some reason, my mouse cursor has gone. It's going to be interesting. Actually, I think we can update this as well. So I can't resist a bit of eye candy. And instead of Visual Studio 6.0, we might have this one in Visual Studio Code. So you get the idea that, in fact, the log event has become sort of almost like literate programming, right? Like the data and the text are interleaved, but they're not really the same thing. They haven't been combined together. And of course, at the console, that's not really going to make much difference, except to maybe make the task of scanning through logs a little bit easier if you can highlight some interesting things about them. But what that does mean is if we do go and we blast that out as, I still have the problem of no mouse cursor, say as JSON with a compact JSON formatter. There we go. Same events out to the console again. You see, we've got the same log statements, but it's producing an event with the template here, which is hello number 0, 1. And then we have these properties attached. 0, which was that first placeholder, has the value 0, 1, 2, 3, 4 as we iterate through the loop. And 1 keeps that string value, and Blumhardt there. You see we've got a little bit more attached there. We'll have a look in a minute. So, of course, we're not also going to write a lot of JSON to the console. But when you've collected thousands of log messages, obviously, from different sources, naming properties, things like 0 and 1, is going to get tiring very fast. And I mean, writing regex is bad enough. I can't remember whether I've got to have a back reference to the first capture or the second capture half the time, or whether indexes start from 0, 1. So Serilog has a little twist on this, which is to allow you to name these placeholders rather than keep them as indexes. So it's an extension of .NET format strings in a very, very slight way. You'll see that everything else that happens in .NET format strings still works with Serilog, of course. They're completely backwards compatible so that you can take your log4net code and move forwards to the new world. So here we've got the number, call it counter, and we've got the name there. And if we get the same JSON out, you'll see that we kept the same template, but instead of having numeric properties attached, we've got counter 0 and name, my handle there. Let me know, by the way, if the font size is no good down the back there. It seems pretty huge from here, but I've got my face right up against it. Hey, if you were really observant too, and I keep forgetting to mention this, but I think it's really cool. If you use resharper, who's used resharper? Yeah. You write a format string, it highlights the format string, and tells you if you have, say, put 2 indexes and only 1 property at the end. So you might be a little bit hesitant to lose that with Serilog. Someone has written a really cool Roslyn extension called Serilog Analyzer. And you see, in this case, we've got 77 there as underlined, and you get a little squiggly. And if my imaginary mouse cursor can mouse over that, you see error while binding properties. Positional properties are not allowed when named properties are being used, and so we can change that back to counter, and we get rid of the squiggly, hopefully. So that is a VS extension that you can pop in, and it will help guide you and make sure that you and your team are not kind of just creating random syntax as you use Serilog. It produces errors through the Visual Studio Code analysis system, so I have it turned on as it gets picked up in warnings as errors in my build. It's a nice little extension to VS there. Okay. Alrighty, so we're probably still not going to get a realistic appreciation, though, of what it's like to use Serilog when we're writing JSON to the console. You could write JSON to a file and then use some tools to pick it up and then ingest those files into something else later on. There are plenty of tools out there, I guess, for like document databases and the like that you could pipe those into. Serilog has a notion called syncs, And each sync in Serilog is essentially like a target or an appender in nlog or in log4net. And a sync is a destination for logs. And most of the time, Serilog wants you to cut out the middleman. You can pipe your log events from Serilog directly into a database, directly into MongoDB, directly into SQL Server, all those kinds of things, or into Elasticsearch or Splunk or Seek or things that we'll look at a bit further on. And the nice thing about that ecosystem is that there's really good support out there now for JSON documents in a lot of different data sources. We'll have a quick look at Postgres because I think that the JSON support Postgres has is really interesting for this use case. So this is the same program. Oh, damn, I showed you all my, my username and password for my local database. Lucky I'm not on the Wi-Fi. So we'll write the same messages out. And if we pop up over to the console, you see we can do a select from logs here in a little Postgres session, run our app. Okay, change our startup project. Nope, not debug. Yeah, there we go. Okay, so run that. We don't see anything at the console anymore. But now if we whip over and look at the output in that logs table that you can see the big block of configuration for there, here are those same events in a Postgres table. And Postgres is really cool because in addition to being a SQL relational database, they've really worked hard to extend it to cover a whole lot of interesting modern use cases. And one of the ones that we're seeing here is that in that properties column, let's do it again. Come on. Okay, in that properties column, we've got the first class properties that we wrote out at the console. And Postgres actually has an extension to SQL that can let you zip in and filter based on values in those properties. So imagining that this is a big heterogeneous log stream, we can say where properties counter is greater than the value 7. And then we just get those individual events out. So we've got a message in there that's as good as any kind of text logging message that we previously would have used. And yet we've been able to zoom in and just grab those events that we're interested in without any log passing anywhere in the pipeline from right back here where we wrote the log event to the Postgres table. So that table is just generic. We've got a JSON column for the properties. So we haven't had to do any more work at all to go and query our logs based on structured data than we would have really had to do to just record a dumb text log in a file. Postgres is not the only place that Serilog will send logs to. We'll have a really quick look at Seek, which is what I spend my days working on these days. Okay, I'll just guess where my cursor is. We can write to multiple destinations at a time. Seek's good for showing this stuff, especially offline, because I can run it locally. And hopefully we'll see same events go out to the console. Okay, and this is a web UI to get at those very same events. So now we're taking the same lot of events. We can write a text log to the console. We could write a text log to a file, or JSON to a file, or JSON to Postgres, or send that to a log server like Seek. And in all those cases, we've got the combination of the text logs as well as being able to do things like, say, counter is greater than 7 in a first-class way where the value from the log file keeps its type, and we can jump in and use that property without having to tell the system anything more, which, if you think about it, it's obvious. The problem in the beginning that we're working to get around here is that we were throwing away information. So there's not, so there's not anything that we're really doing that's magic. We're just stopping doing what was originally hurting us. You know, we're writing a log event. We throw away all the information that we really need later on when we want to do diagnostics. So we saw how message templates take us through from originally just doing plain text formatting to having that capturing stage separated out to record a structured event as well as the text that it's rendered into. And we can see how having that intermediate step gives us the ability to choose whether or not we're going to render or whether we're going to serialize into some other format. One thing I didn't show in the demo is that it wouldn't really be a first-class structured logging experience if we were restricted to just recording simple strings and numbers, because if you're writing JSON objects to a log, with an API designed for that, then you can write arrays, you can write structures, and you can capture all sorts of other information from your program that way. Serilog hacks this in a sneaky way by introducing the structure capturing operator, which is the little @ sign in front of the property name. By adding that one in, Serilog will actually serialize whatever object appears in that position and include that as a fully structured object in the log event rather than using toString like you would without the operator. And this has led to all sorts of hilarity in the past. Before we really had thought about it a lot, we'd get bug reports from people who would say, log an object that had a system.type in there, and you follow the serialization through the properties attached to system.type, and you've got type.assembly, so you start serializing that, and assembly.declared types, and you start serializing those. And really quickly, you find yourself in gigabytes and gigabytes of data. There are definitely limits in there to protect you today, but we still view serializing stuff into a log as being something that's a pretty strong opt-in, not really something that you would do by default. But now you know how Serilog got its name. It's a serializing logger. So is this at all a good idea? We thought so for a while. It's nice to see that it has actually caught on a bit outside of Serilog as well. And if you use Serilog with .NET Core, then you find that you can use message templates like that with the Microsoft.extensions.logging API over the top of that. And even MVC itself in the .NET Core version, like this one, is actually using message templates to generate some of its internal events. So when you log your requests and things out from a .NET Core app, you'll find that all of the things like the action name and controller name that appear in those messages, they're all now actually first-class structured properties that you can search and filter on, whether you're using Serilog or not. But Serilog's got a good mature implementation of being able to take those things and send them to all sorts of destinations, while the logging infrastructure in .NET Core is still mostly a facade over different implementations like Serilog. But to try to make sure that we don't really drift off in just making, I guess, arbitrary changes to the format in Serilog, and also to give people a pointer to other implementations, there's also a site out there you can go and have a look at where you see a few more places that message templates are implemented. So in addition to .NET Core, there's also nlog 4.5 has now created an implementation that's in beta, or alpha, I should say, I think at this time. There are implementations for Java and Rust and Python and a couple of others. Okay. All right. Okay. So this is a slightly more realistic log stream. It's still much tidier than the logs that I've been forced to spend hours eyeballing in different past lives while sweating profusely. But this is more like the kind of thing that you'll see when you're actually using Serilog to collect data from a real app. And this one's just a test data set that's collecting data from some kind of admissions portal, typical kind of hospital admissions system. And you see that we've got the same, oh, and I've got a cursor back, yes. Okay. You'll see that we've got the same kind of structured data here with a lot more properties attached, but we can ignore those for the time being. So in this instance, we can do things like we can go and take our commit time elapsed, which has been added to the message. We can find that, or we can do things like, 1,000. There we go. We can plot it over time, et cetera, et cetera. But interestingly, I mean, those are the kinds of I guess bonus features that you get from from using something like Serilog. Most of the time that I turn to application logs, like it's really nice to do analytics and everything else, but most of the time I've got a problem to solve. And the things that terrify me are usually the unknown unknowns. They're not the things that I know about. I mean, I know I've been watching my commit time on transactions as the system's been running for months on end, and I know that they're not going anywhere fast. And so when a bug report comes in, generally from the field, all you typically end up with is the idea that at some stage in the afternoon, something didn't happen that should have happened, and in the logs there somewhere is the clue. But the logs look normal, and you can scroll for, you can scroll for hours, and there are generally, even from a fairly quiet system, thousands upon thousands of logs, and there's a very strong limit on how much data you can actually take in by eye until the coffee cups start stacking up on the desk, and you still haven't found any clues, and the system's still not behaving properly. It's a horrible experience. One of the interesting observations that we made through building Serilog is that in even a fairly large system, there are always orders of magnitude more events than there are kinds of events. So we might have 1 million events in this stream since yesterday morning, but the application's only been running a certain number of scenarios in that time, running a certain number of lines of code. And so once we've actually looked at an event for, say, this SQL Server circuit breaker state is open, we know that's got nothing to do with the problem or unlikely to have anything to do with it. The nice thing that Serilog lets us do is that because all of the events for this message have actually been generated from the same template, the template is going to be circuit breaker, breaker name, state is state. And all of the events that were raised by that same line of code, whether they've got garbage in those properties or not, can all be identified because you can track them back to the type. You can track them back to the message template. And in this case, we use a hash of that message template to be able to zero in on finding the events, which is great if you're doing the analytics kind of case, because you grab all of a particular kind of event and then just go and pluck out the properties to do analysis on. But more importantly for me is that once we've decided that we're not interested in that event anymore, we can just exclude that from whatever view we're using to read the log stream. And if we do that for a little while, like the problem has nothing to do with claim checks. And I could tell you, by the way, give you an idea of what's left. So we've got 52,000 events to get through. But as we zoom our way in, we're not interested in that claim status, so exclude, not interested in that, exclude. And as we work our way through, looking at different kinds of events that are not going to be relevant to our problem, we start to zoom in on maybe things that are more interesting for our particular scenario. And eventually, you would hope, given a bit of determination and probably still a few cups of coffee, okay, it has nothing to do with update checks. And hey, this is the event you can't afford to miss. So we probably sifted through 60,000 events by excluding only a dozen event types. And for diagnostics, this is a super powerful side effect. And most of the time when you first see Serilog, you hear about all of the advantages of being able to query based on properties and filter based on properties. But in practice, the thing that saved my bacon the most it has been the ability to go and actually sift out uninteresting things like triage particular kinds of exceptions or triage particular kinds of warnings and make sure that I can separate out the data that I'm interested in from the things that are obviously just noise. It's kind of the Demtel moment, isn't it? It's like, wait, there's still more. We've got this. So we're just looking at those in Seek, of course, but it's not a Seek feature specifically. Even if you're writing a log file with Serilog, you can still plug in an enricher to attach that hashed message template value straight into your log file and then be able to go and search using whatever tools you use for that plain text processing and still get the benefit of having event types there first class. So you can see here we've got the the full event is actually rendered into the message, and then we just sneakily hash the template using something like Murmur or Jenkins hash or something like that, and stick that value in there in a way that we can search it out again later on. Okay, so just to look at the second part of Serilog. So on the surface, we've got the nice capturing syntax for recording structured data. And then down at the end of that pipeline of event processing, we can pop these things into all sorts of different syncs. But in between, we've got events that are captured from your log statements and then sort of make their way through a pipeline of filtering and other kinds of processing. And by treating events as a first-class entity and having an API that's really tuned for them, we can do some interesting things in Serilog. So just a word on terminology. We're mostly talking about correlation here, which is the ability to connect the dots in a very large event stream. If you've done work with WCF and correlation, or the correlation ID header in a web application, you're probably thinking of correlation as being something that's about a single identifier. Serilog, though, is geared strongly towards supporting a more natural style of correlation, where, say, you've got a stream from your application of millions of events. If you've only got one dimension to start filtering down, it's going to be very hard to start to home in on a particularly interesting set. And to really help make that possible, not only do we collect the payload in each event from the message, Serilog allows you to attach all other different kinds of contextual information to an event, so that we might know, for instance, that the problem was to do with this particular customer, and so we can filter on customer ID and then switch on to another dimension. It was when we were processing a claim for that customer, so we look at the claim ID and the customer ID, and we can start to narrow things down that way. And so you can see there's really like an infinite number of possible ways to correlate different sets of related events in this kind of system. Yeah, and that was that slide. So once Serilog started producing fully structured events that way, it really opened up the opportunity to go and think hard about how to make those events richer and more useful for diagnostics. So here we've got another. I still don't have any cursor. Oh, but if I scroll, I do. Here's the trick. Okay. So now we've got another console app, similarly trivial to the one that we were looking at 5 minutes ago. It logs a sequence of events. It logs a startup event, a done event, and then within each iteration of the loop, it's bookending that calculation with some, we're going to do this, we've done it, and then we do it, and then another event that tells you that we've done it. When we run that, you see, oh, actually, let's leave that for now. You would have seen over when we were looking at the last data set in Seek that we're narrowing down to a particular demo using this selector over on the right here. What we're really doing there is that each of those little programs is using an enrichment with a property to be able to separate it from all of the other programs that we're running in the same session. So in this case, we want to enrich it with the demo property. And this one is called the enrichment demo. And here you see the most basic and fundamental way of narrowing down to a set of events with Serilog. Oh. If we refresh that again, you see now all of those events that came from that application have got demo attached. We can find that, and then actually I believe that we've already set up a filter for it. There we go. So Serilog lets you pin individual properties to an event, and most of the time that's going to be something like the name of the application, or if you're just running one application, it might be the name of the particular service component, or sometimes the environment that you're running in. You might want to separate logs that are from dev or test or acceptance testing. That static kind of enrichment is very useful but fairly limited. It's more frequent that you'll have some kind of value that changes as the application runs. Typically, these start out with things that you'll be familiar with from using log4net or nlog, like you say enrich with thread ID. Being a console app, I hope there's nothing crazy going on here and we actually do get what I expect. In that case, it's going to be that doesn't look so good, does it? Perhaps the little selector is not the right one. We'll call that one. There we go. Somebody can point out my typo later on. So in this case, the thread ID is always 1, but Serilog has a little toolbox and a number of different packages that you can add that go and enrich events with different values like the thread ID, the current HTTP request ID, the current machine name, the logged on username. All of these pieces of ambient data can get attached to an event without you really having to worry about it at the place that the event is logged. Getting down a bit more specific, and I think the most interesting piece of the enrichment API in Serilog is something called log context. And as I said earlier on, one of the principles that Serilog really tries hard to adhere to is not to go and make assumptions about being the only logger in a process and not assuming that any particular static state belongs to it. So to be able to get your ambient context into Serilog, you need to opt in with enrich from log context. And from then, we can go and do do operations with log context, like push property onto the stack. In this case, we'll call it iteration. Sorry, that should be, and we'll put I there. That should be. Property. There we go. Sorry about the clicking. The last thing I wanted to do at 9 a.m. on a Friday morning was prove that I'm not a keyboard warrior. But so in this case, in that using block, all of the events that have been raised will have the same iteration property attached to them. If we zip back and look at those, see here we got the answer was 9801. If there's something wrong with that answer, then by using the property we've attached through the log context, we can go and find all of the events that were related. That was 99. OK, so now I know what 99 squared is. Great. So the log context is useful for things like perhaps it generally appears in middleware more than it appears in user code. But if you've used something like mass transit or in service bus, you'll typically find that your whole application is built up with just these little islands of activity that occur in response to something like a message coming down the bus for a particular order or for a particular customer. And when that process begins, you've got the opportunity to push that message ID onto the log context or push an HTTP request ID onto the context. And then if something goes wrong in the processing of that message, you can go and just pull out all of the events that occurred only within that logical thread of execution. This is part of where Serilog's async friendliness also comes into the picture, because what is a thread of execution has changed about half a dozen times over the life of .NET. We used to use logical call context and a few other things. So now Serilog actually uses async local of t for that, which is a fairly new type if you're on a framework that supports it. And that way it follows a thread of execution even if there are awaits embedded in there. So you can run this in async code just like you can in synchronous code. So the last kind of way to approach enrichment is the DIY. And I think the thing I really like about Serilog is that there isn't really a lot of magic in the library itself. The pipeline is really just a pipeline cobbled together from different plugins. And in this case, you can quite easily at this point, if you want to say put an event type locally into your logs, then you can write a new event type enricher. And if ReSharper likes me today. And all of these things are implemented with something called iLog event enricher, which is plugged into the pipeline. You get a log event that comes through the process, and then you can inspect that event in an enricher and see whether or not there's anything interesting about the event that would mean you want to add more data in there. So people have used this for things like pulling values out of the exception.data property to actually tag on the event as first-class properties when an error occurs. So say, if you're using Postgres, you've got a whole lot of data attached to each event that comes back from Postgres that gives you things like the internal Postgres error code that raise that exception. And whatever you're working with, you'll find there's similar cases. It's also possible to do things like look at the message template and generate a hash that you can then go and include in your output format to show in a log file. And enrichment is really an area ready for all sorts of creativity. So at the moment in Serilog itself, we've got things like the APIs for doing fixed values for the ambient state, for scoped state. You can also attach properties to an individual event using an enrichment API called forContext. So take log.forContext, pass a property value, and then that gives you a customized logger that will attach that value to every other event that you raise through it. But where this all fits into the big picture, Serilog has quite an interesting pipeline. It's in a fixed topology, which you probably feel initially might be limiting. Of course, the neat thing is you can chain multiple pipelines together. But events in a Serilog pipeline go through, if they pass the minimum level check, you can customize the way that values are captured. So just like JSON.NET, you can say, configure the serialization for user objects and exclude the password field, say, if someone logs those. And so at that capturing stage, you can go and do things like implement custom policies for, say, if you're working on a system that does a lot of GIS, you might want to log GIS objects instead of position objects instead of as strings. You might want to automatically convert those into a particular structured format. Once you've gotten through that process of capturing the event, then things like the enrichers that we've been looking at plug in. All of the ones that we were using previously in the demo, like the thread ID enricher and log context and everything, they're just based on a simple API that lets you inspect the event and attach more data to it. It can be a little bit scary, I think, at first, though, to crack it open, because just like JSON.NET, if you've worked with the dynamic data in JSON.NET, then you'll have seen things like JObject and JArray, and you might ask kind of like, why don't we just have object and array? Serilog is a bit similar. It's got an object model for representing property data. The reason for that is, and I bet there's at least one person here who's been sweating it since the beginning, of course. Going and grabbing objects from your programming, from your application, sticking them in events and then passing them through an asynchronous pipeline is kind of like a concurrency nightmare. So we realized this early on, and Serilog uses the type system that it has built into it, like you'll see scalar value here for thread ID. It uses that to enforce that only a certain set of values will actually be carried along with a log event, and everything else either has to be turned into Serilog's internal types or converted using toString. So all of those values then, once they're attached to a log event, are immutable, and therefore mostly and reasonably safe to do things like put in a batch so that they can be batched up and shipped maybe over HTTP by a worker thread. So there is a little bit to contend with if you want to jump in and write your own enrichers, but it's certainly not super complex. The final stage of that pipeline, of course, is filtering. Client-side filtering is something that I always imagine would be really heavily used in Serilog. You can write a filter expression for your Serilog pipeline that says exclude all of the errors where the error code is whatever, so that you're not collecting a lot of it. Over time, though, I think the people using Serilog have tended to move on from log files and on from things that have those kind of constraints and more towards collecting things in back-end log servers. And these kinds of systems typically have mechanisms to filter at the server side, and it's much more ergonomic to go and exclude events as they arrive at the server, or have short retention policies that knock events out based on a set of criteria than it is to actually go and update applications with filters. But the filtering is pretty sophisticated as well there if you do find a use case where it's important to you. So that's the real whirlwind tour of what makes Serilog Serilog. We looked at message templates. Hopefully you're itching to go and template up all of your log messages now, or even if you've got log4net or nlog, go and switch them and start collecting things with those numeric properties, because even like filtering for an event based on a numeric placeholder is not the worst thing in the world compared with, I don't know what kind of regular expression madness you'd otherwise have to do. And we looked at enrichment and how to kind of slice logs up across a lot of dimensions that way. I think I'm just about short on time now, but I've got some time for some questions if there's anything that anybody would like to dig deeper into. Sure, yeah, go ahead. Yeah. Well, usually I use the static log class only because, yeah, I use a lot of IOC as well. I've suffered the IOC bug for many years as well. And I do in my apps as well inject pretty much everything that I can't get away with making static and stateless, like, functional style stateless. I've tended personally not to inject dilogger just because when I look at a component for IOC, that constructor list is such an important piece of documentation for me, and I want to be able to look at it and see really quickly what the component's going to do. I don't really want to have ilogger in all of those, but you can, of course, wire up your IOC container. I've published one that I published a NuGet package called AutoFac Serilog integration, I think, that gives you an idea of how Serilog can be configured that way with AutoFac. The ASP.NET Core or .NET Core logging subsystem has something similar that it can do constructor injection that way. It's definitely a possibility and not anything kind of prescribed against. And that's actually the original reason, of course, why there's no static state in Serilog, because you might want to configure IOC so that some components get a completely different logging pipeline to others. One of the instances that might occur is sometimes you can configure a logging pipeline with a different set of policies to make it into an auditing pipeline. So there's another place where you might want to kind of choose that implementation rather than just use log, the static class. Anybody else? Anything else? Yeah, sure. Implementing your own sync, yeah. We could just about do one now. I'll try. I love it. Yeah. Look, I love a good challenge. I did get my morning coffee and I wasn't that. So your own sync is. That's the page down button. So the syncs as well, as the underdog, Serilog is really optimized for being easy to get going with. I didn't think when I first started working on the API that anybody would spend a lot of time working on writing syncs for a brand new logging library that was unproven. It's kind of like chicken and egg. So the syncs are also very easy to write. We can do something like console. Do I not have system.console? We can write out just the timestamp. Log event timestamp. Hey, and our enricher still throws, but that probably gives us another opportunity to see Serilog in practice. So Serilog did. There we go. There's our other sync in action there, printing out the timestamp. There's a bunch of machinery for doing things like formatting events out as text using a format string and those kinds of niceties. And there's a range of JSON serializers that you can use to do JSON-based syncs. So you see, even though our enricher was throwing every time an event passed through there, Serilog will collect up those exceptions and just send them to an internal log it's carried that fail stop perspective through from log4net, where the logger shouldn't bring down the app if it can avoid it. Generally, of course, because your app's at that point crashing, and fire can't be fought with fire in that instance. So yeah, there are lots, but given that there are probably about 100 syncs out there, I think now even more, you don't generally find yourself writing new syncs too often. You can pretty easily grab the code for any of those ones from GitHub or NuGet and adapt. Any other questions, or we have some time? Yep.
You've got the code-based way for configuration, which is nice to remove a lot of that stuff that you never end up changing anyway.
Yep.
But one thing that you do quite change between environments is that minimum log level.
Yeah, so the configuration subsystem, so the question was, how would you change the log level without configuration? So Serilog does have configuration, in fact, and here's another opportunity to demo the, I'll switch back over to the other example, but the fantastic Serilog analyzer. So you can configure Serilog completely using XML config if you want. It's just that you need to add read from app settings and install an app settings package, or read from configuration to use the ASP.NET Core or the .NET Core JSON configuration. But the analyzer has this great little hack where you can write your code first and say, in this instance, let's add minimum level to it, debug. And now we're going to go and put that into app config, Alt-Enter. We've got a choice between, that says show app settings config, show app settings.json config. I'll just hit enter, and we can actually get the Serilog analyzer to generate the XML config there, and then copy and paste that into the config file and get going. So my hat off to the people who have worked on making this thing go, because it really, it does show how having code first gives you a lot of metadata to work with to do these kinds of cool things. So, any other questions? Yep.
With the write to sequence method,
See.
would you use that to write to Splunk directly?
You'd use write to Splunk. Yep, yeah. There's a package for Splunk. There's a package for App Insights, another very popular one, and Elasticsearch and Loggly and Logger. And yeah, there's typically, all of those different backends have different characteristics for how they like events, and so the syncs are all rather specialized for them. And the last question down the front. Yeah.
Well, I was just going to mention, it might be worth mentioning that the ASP.NET Core logging is designed more as a pass-through than a
Yeah.
system.
Yeah.
One of the first things I'd love to do is add Serilog to it, and then whether you're using the Serilog directly or injecting unlog or consent.
Exactly. Yeah, that is a very good point. So you can also, with the ASP.NET Core iLogger subsystem, or I should say it's the .NET Core logging. It's just the habit of having watched ASP.NET Core develop. You can actually plug Serilog in there and have the framework write all of its events through its iLogger, and then continue to use Serilog directly yourself in your code, or chop and change, pick and choose whichever API you want. Because yeah, ultimately the .NET Core logging subsystem is a facade, and you see that there are providers out there already for things like Log4net and nlog. Actually, I don't know about Log4net. Maybe I need to go and check it out again. Okay, I think we may have one last question. Yeah. Okay, good. Oh, sorry, was there one? No. Okay, great. All right, thanks very much for coming along. Really appreciated your time coming out to see this one, especially so early. But yeah, catch me if there's anything else that you did want to know a little bit more about. And I hope that you can take away some things that make your life debugging and diagnosing things a bit more pleasant in the future. Definitely let me know if you have some wins. Okay, thanks.